In lesson 2.5, we're going to look at how you would go about measuring irregular shaped areas. And there are basic two rules that we're going to consider. One is the trapezoid rule, and the other one is the Simpson rule. Anyway, to use trapezoids, what we do is we break the shape up, whatever this irregular shape is, up into trapezoids, using an interval width, which is called h. Now, in this diagram here that you see, down here at the bottom, where we've got this blue arrow, blue line, that's our interval h. Okay, so we want to make sure all these other lines are that same distance apart. Okay. And then the next step we're going to do is measure the lengths across the shape. Okay, so that means we're going to go back to these red lines here. We're going to measure those lengths going across the shape. And then we're going to use the area of a trapezoid to help us solve this. Okay, so let's see what we can do with that. So here we've got, this is Lake Ontario we're trying to measure. So the h, the distance in between those measurements, they've allowed that to be 26 feet. Notice that's right here, the 26 feet. That's this measurement. And so we start off at nothing, at 0, then we're at 26, 52, 78, and so on, because we're adding on 26 feet. Then they want to measure the length across. So that's the red lines. And for these lengths that are measured across, well, we start here at a single point. So that's 0. But this first measurement going across here is 46.7. And then this next second measure going across is 52.1, and so on. 59.2, 60.4, and so on. Now, those measures we're going to refer to as being y's. Okay, so those measures going across, like this y sub 0 is this 0 here. Y sub 1 would be this 46.7. Y sub 2 is this 52.1, and so on. And then this is our formula. Now, our formula says for the first value, you just leave it as it is. So whatever that first number is, that's the value. The second number, however, though, the second length, you multiply it by 2. And you do that with all the other lengths. You multiply it by 2 until you get to the very last one, and that just stays as it is. The y sub 12 term stays as it is. So in this case, I hope you can read this down here. We've plugged in the numbers for this. 26 is the value of h over 2. And then we went back to our y sub 0, which is 0, 2 times our y sub 1. So that's 2 times 46.7, 2 times 52.1, and so on. We just kept plugging in, and we're working across here until we get all of those values in, and we get to the very last one, which is just 0. When we work all of this out, what comes up as being our answer is this: 19,500 kilometers squared. Now, that's an approximation, but the actual area is 19,477 kilometers squared. So this trapezoidal method gives us a pretty good approximation for the area of this irregular shaped figure. Now, the second way that we could be doing a problem like this is using what's called Simpson's rule. And for Simpson's rule, it is similar. We still have these equally spaced out. This value of h is the same going across here for each one of these. So we're equally spacing those out. And so we have these parallel measurements across. The one thing that's different, instead of connecting this with straight segments, we're connecting them with curves. Okay, so we're using these curved arcs in this, and when we make the connections. Now, the formula for this one looks a little different. Notice that the area is whatever the value of h is divided by 3. And then we have y sub 0, our first measurement right here. And then for y sub 1, we multiply it by 4. Whatever that length is. For y sub 2, we multiply it by 2. Y sub 3, we multiply by 4. Y sub 4, we multiply by 2. Y sub 5, we multiply by 4, and so on, until we get to the very end, and at the very end, here again, that stands alone, the y sub n. So let's look at a quick problem with this one. So in this one, we want to measure a parking lot that's proposed for the riverfront area in a town. So they measure the width at equally spaced intervals, the 100 feet. So what that is referring to is this distance in between here. That's 100 feet. This is 100 feet. This is 100 feet. That's what we mean by the interval. And notice that there's 6 of these. So our first y measurement, our y sub 0, is 407. Now notice that stands alone, 407. And our last y measurement is 495. And here again, that stands alone. We put h over 3, so 100 over 3, and then we start our multiplying. 4 times the next one, 483, 2 times 382, then 4 times 378, then 2 times 285, then 4 times 384. And when we do this, all this arithmetic, our final answer, our approximation, ends up being 241,000 square feet. Now, notice here the statement. Simpson's rule usually gives us a better approximation, and the reason for that is because of the curved connections instead of the segment connections. But we can use either one of these to approximate an irregular shaped area.